So with the parts of a radical, we're used to the radical, but we may not be used to this index that's out here. That's the proper mathematical word. Many times you hear us just use the word root. It's the third root, square root, cubed root, whatever root it is. So those are a little interchangeable, but again, we like to be proper as best we can. And so when you're looking at a radical, they actually can be written as exponents as well. So what we're looking at here is that your index or your root is out here. Your exponent, if you have one on a variable or a number, is inside here. And so if you're trying to get to this part, you're doing the exponent over the index. You're just taking these two numbers, putting them over each other, and you can turn it into an exponent, which can be helpful sometimes. If I don't see an index or root, we assume it's 2, like a square root. So as you see in the examples over here, if I have a 4 as an exponent and a 3 as an index, it'd be 81 to the 4/3. If I see a square root, it's 81 to the 1/2, because we assume if we don't see an exponent, there's a 1 there. And we assume if we don't see an index that that's a 2 out here. So write the rational expression in radical form. Okay. So I'm going to put my radical. There is my exponent. There is my index. Put my exponent. Put my index. Well, do I need to simplify that? If you're just being asked to write it in radical form, no. You bring it to here, you're good. Would it be wrong if you actually did 15 squared and got to here? No, it's still in radical form, but if you wrote it that way, I'm probably, if you asked me to come up with the original problem, I'm probably not going to come up with that, because that'd be 225 to the 1/3. That's the better route to go. And so with any of these, exponent, did I have to put the 2 there? No. Could I have just put this? Absolutely. And if you were looking at an answer key, that's probably what you're going to see. So now, for a moment here, maybe, the fastest freeze ever for number 3. Get your radical form drawn in. There's a couple of different ways it could look on number 3. So try that out if you haven't, and see how things are going with it. So this ends up being one a little bit like the one right above it with the 81. 1/2 is just saying square root, but if you're a creature of habit and you want to put an exponent and an index, do it, okay? It's not wrong. Either one of those would work. And as you've come to see in here, if we do things one way, we like to be able to undo it as well. So write the radical in exponent form. Okay, I'm going to actually put my exponent and my index back in. And when we're going this way, we just have to remember it's always exponent over index. Just like E comes before I in the alphabet, same way when you're making that fraction. The exponent's got to come first. Exponent over index. Now I know number 6 looks different, but it's not. So go ahead, write that one down. Yes, the screen is frozen. It's not Hardy making a boo-boo, which I have many times in the past. But just make sure that you've got this set, because the last thing I want is on the next quiz you flipping them and getting them backwards. That's a terrible way to lose points. So 2 to the 5/6. So even if the exponent is outside parentheses like it is here, you're still doing it the exact same way. Don't let the parentheses throw you off when it comes to those. Now, options. We like having options. So for any real numbers, okay, and this is the best way of looking at it, depending on signs that you see on the outside of your radical, we have to respect those. In other words, we have to consider them. If you just have a square root, you get an answer, okay? One answer. If there's a negative hanging outside, this is the equivalent of having -1 times the square root of 25. Or -1 times +5, which is where the -5 comes from. If there's a plus minus in front, just means you're going to have a plus minus in front of your answer. Okay? Getting you ready for some things. And then our same rules that we saw up above. Just a fancy way of rediscussing the radical to exponent rule. So why do we say this? Because there's a couple of ways for me to get answers when these end up being values maybe that I don't want to have to necessarily deal with. So evaluate this. Okay, my first job is I could turn it into an exponent. 343 to the 2/3. Grab my handy dandy calculator. 343. There's my exponent button again, right above divide. 2 divided by 3. Bam. 49. You could also, I'm not as big of a fan of this. The more buttons I have to press, the less likely I am to do it. But I also could go math. Notice on number 5, there's an X out there for the root. Like you have square root, you have cubed root. You can always go to the X one in general. And then again, you're just saying, okay, well, that's 3. And this is 343 squared. You get there that way. That's an option. Both of those are going to get me to 49. I'm even going to tell you about one more way you could do it. But again, it depends sometimes. You also could look at this like this, where you take out your chart and you say, hey, 343, the cubed root is 7. So the cubed root of 343 is 7. 7 squared is 49. You can break it into pieces, do the root first, and then do the exponent. Totally legal. So you got 3 different ways, 2 with a little bit of, thank you, with some tech, and 1 using your noggin and your chart. They all get you there at the same time. So lots of options. We'll just leave it at. Okay. Evaluate. Leave your answers as fractions or whole numbers. We have lots of options again, so pick your favorite from the front. I am always, I'm going to admit it, 9 times out of 10, I am going to be a fan of going back to the exponential form. To me, it's the fastest. And I can also do it on any scientific calculator. It doesn't have to be one of these. But if you like the other little plays with Math 5, or the cubed root of 125 is 5, 5 to the 4th power, that works too. Let's see here. Now this one's ready to go for us already. We just got to type it in. We're not doing the decimals. Don't do the decimals. 8/27. Okay, tech is not a bad thing. And here, that's just a square root. So if I wanted to do that, I could. If I wanted to do the math thing, I could. Except that's just squared. Now, if there's parentheses there, should I use them? Probably. Can I get away with it sometimes not using them? It depends. If we're dealing with positive negatives, you're probably going to want the parentheses there just to play it safe. You kind of see how things are going. Now, the one little twist with these, this gets a little more interesting. Okay? It seems straightforward enough to look at these and say, okay, if I'm taking square roots or I'm doing my exponent over my index, that should be enough to take care of this. Okay? Sometimes we're going to have to play the game with the absolute value like we did before. So that gets a little more interesting. And there's a couple of ways you can even look at this. More times than not, if you just follow what you normally do, you're going to be fine. Like for instance, here, you look at this and you say, okay, the square root of 49 is 7. 2 goes into 8 4 times with our rules from before. I'm done. That's good. Yay. Or if you looked at this one, you'd probably look at it and say, well, wait a minute. Here, I'm just doing, and it's in parentheses, exponent over index. 6 divided by 3 is 2. But there's a negative outside, so it's like I'm multiplying by -1. Common sense, okay? It's a good thing. It works. When we get to this even-odd thing, okay, let's be honest about it. Yes, there's mathematical lingo I can play here with absolute value, but let's think about it for a minute. If I did -2 to the 4th power, now, here's where I got to have my math sense about me. -2 to the 4th power is 16. If I do the 4th root of 16, or 16 to the 1/4 power, I get +2. Okay? Now, if I went and I did math 5, let's test it out. 4, -2 to the 4th. Okay, I'm still good. So it's not like you have to know some fancy special trick to get there. Here, you look at the same thing. Here's where you've got to be a little more careful. You're like, wait a minute. -2 to the 3rd is -8. Wait, Hardy, we can't take the square root of a negative. You're right, but you can take a cubed root. If you just do plain old -8 to the 1/3, exponent over index, you can do it. You can type that directly into the calculator. You're going to get there. What I'm trying to do is put you at ease on, you don't have to be all tense about, oh my gosh, do I need the absolute value or not? Follow the rules, and you're going to be okay. Okay? If n is even and a is less than 0, then a has no real roots. Okay, what does that mean? That's the one exception. We're going to star this. So like, let's say, for instance, I get the square root of -4 to the 4th. So I go to my calculator, and I'm like, all right, square root of -4. You're like, well, wait a minute, that came out okay. So what's the dealio here? So here, if I did go ahead and do -4 to the 4th, it comes out positive. It's going to be okay. But what we've got to watch for, okay, and this even, I just want to make sure I did one thing. I didn't change it. I didn't. That's the one time we're going to watch. If, wait, did I misspeak? A is less than 0. Then it has no real roots unless you do the absolute value. So I'm going to go back. If I could erase myself right now, I would. Stick to this. Don't concern yourself with that. I'm even going to do this. I'm going to go this far. I'm going to get yelled at later for doing that, but that's going to cause more issues. For the, like, I can think of one other example that would cause a problem. If you follow the rules that you did up above, you're going to get to right answers. And we'll discuss, if the one issue does come up, we'll discuss. We don't need to cause chaos, though. Okay. Simplify. Hardy. Does this mean that 9 times out of 10, I can just go ahead and, you know, pop this in my calculator, to be honest? Yeah, it is. Any route you want to go, if you're an exact type of person, you're like, I'm just going to type this in exactly like I see it, get an answer. Okay. Ooh. But I can't put the variables in my calculator. You're right. So if need be, at the start, oops, got a little too quick there. Hang on just a second. There we go. Why did it do that to me again? I can play this game too. Now here's where I've got to watch it a little bit. So the cubed root of negative 27 is negative 3. 3 goes into 6 twice. But that negative is sitting outside still. So this is, again, where I use my common sense and the logic I've had since pre-algebra, and I go, well, wait a minute, negative times negative is positive. And I work my way through there. So, little things that we're on the lookout for. Ooh, what if it's not a perfect square? This reminds me of something I saw in the quiz. A lot of you, let's say this was the problem, did a good job at finding a root, but you didn't necessarily find the biggest one. So here I look, and I'm like, okay, I do notice 4 right away, but always start from the largest squares and kind of roll through just to remind yourself. Four is out of radical jail. 3 stays under. We're going to chat more about that in a second. Now it becomes the division game. 2 goes into 3 one time. You have a remainder of 1. The remainder stays under the radical. 2 goes into 4 twice. Nothing left over. The plus minus stays. But here's the one thing I wanted to chat about quick. I didn't see a lot of this, but I saw some. If you break down a radical, once you break down a perfect square, it is out of radical jail. You cannot break it down again. So when I say that, what I mean is if you have the square root of 16 and that turns into 4, it doesn't mean then that you take the square root of 4 and turn it into 2. Once it's broken down, we're not putting this thing on trial. Twice, it got out. It's on good behavior. Leave it be. Okay? Other than that, that's not going to be bad. Ooh. Fifth root. We're not looking for square roots here, so I'm not just going to do 16 and 2 here on 32. This is where I break out my chart, and I go, okay, oh, look, isn't that nice? 32 is a perfect fifth. It's 2. 5 goes into 12 twice, with 2 left over if you need to do a little side work. 5 goes into 12 twice, with a remainder of 2. 5 goes into 10 twice. There is no remainder. Keep it simple. Remind yourself that little root number's out there to help you. 2 goes into 14 7 times. Leave it. Don't try to get fancy and multiply that all out. If it's in parentheses, don't get cute. Exponent over index, 27 over 3 is 9. Definitely don't try to multiply that out. That'd be a mess. Most of the time, I can't promise every time, most of the time when you get the nasty looking 4th and 5th roots, they're going to be on your sheet. Now, can I type in 256 to the 1/4 in my calculator? Or just that in my calculator? Absolutely. $12 over 4 is 3. We're just simplifying. Don't make life harder than you need to. Now, do I think that you can get away this time with just odds? Probably. Yeah, that's not where I'm going to pull your chain and be like, you've got to do everything every time. No. I did make the exception with the factoring before. This time I'll do it again, and I'll be like, I think odds on page 1 and 2 would be enough to get you thinking through this a bit, which is a good thing. So I will mention, I think I'm going to mention this one. Do I want to? Let me just put it this way. I'll put it this way on video film here. Trust your instinct when you get to this middle part. If you run into an answer that has the absolute value, you're going to see it mainly on the ones with 4s and 6s, okay? Don't frazzle yourself so much. Like if you, let's say you're doing number 21, and you're going along and you're like, all right, 21, there's 4ths, it's 2, okay. And you go 2W, ooh, there's 3 left over. And you do this, and you've got it, and you're like, okay, I'm good. And then you flip it over, and you're like, Hardy, wait a minute. I got everything there, I'm good, except I see the absolute values. Because again, you would have to see something technically mathematically that said assume all values are positive for you to not be putting absolute values on those whenever this is even. But again, I don't want to get you so stuck into the details of things that you're like freaking out with this stuff. But honestly, that's all it is. Anytime you see an even with these and there's a variable coming out, technically you're going to want to put the absolute value on there. So we'll put that out there. But I'm not going to yell and scream at you if you have it, and I don't want you to get stuck on that. If you remember it or you see it on the first couple that you're doing, and you're like, oh, I need to do that, that's cool. That's great. But again, that's a detail that we're working on more later anyway.